Application programming interfaces. Now, if you're in the tech industry or in the software engineering realm, you've probably heard of this term before, but to the uninitiated, it sounds extremely intimidating. I know when I first heard of the term application programming interface, I thought it was something that only super advanced PhD computer scientists would know. And even in the off chance it were more simple than that, it probably takes a long time and is very advanced to implement. And even if I were able to understand it, it probably would take a long time to implement in code. And finally, I just in general thought APIs were super advanced, like their function and purpose was probably so technical that it would be hard to implement or even know about in the first place. Now in this video, if you're anything like me, I want to absolutely destroy those stigmas. In reality, APIs are actually very simple to implement, and I would argue even a monkey could try to implement one. Yes, they can perform very complex tasks, but sort of the whole goal of designing an API is to make it as specific and really simple as possible. And so I hope you embark on me on this journey in defining exactly what an API is so you can feel more comfortable implementing them on your own. Let's jump right into it. Now, according to this really good article by IBM, an application programming interface, or an API, is a set of rules or products that enable software applications to communicate with each other to exchange data, features, and functionality. Well, that's great, but what does exactly mean to communicate between two softwares? Are they calling each other up? Are they sending text messages? Are they swiping right? Like, what's the deal here? In its simplest form, it means that one API is sending out a request with the expectation to receive a response from the other end. At an even higher level, all it really means is one API is simply asking another API for information to complete the request of the first one. And while this is a relatively simple use case, this process can actually be daisy chained, right? You can have one API call another, that API need more information and call another, etc., etc. And it is generally desirable because all these APIs perform very specific tasks. So when it comes time to debugging, when something inevitably goes wrong, you can go ahead and look at where the process broke down and isolate relatively quickly exactly where that bug is. Now, instead of sending text messages, dating requests, or phone calls, APIs actually communicate with each other with these things called JSON payloads. Now, JSON, short for JavaScript Object Notation, is defined to be a text-based format for storing and exchanging data in a way that's both human readable and machine parsable. As a result, JSON is relatively easy to learn and to troubleshoot. Although JSON has its roots in JavaScript, it has grown into a very capable data format that simplifies data interchange across diverse platforms and programming languages. If you're involved in web development, data analysis, or software engineering, JSON is an important data format to understand. Now, that's actually a direct quote from Oracle's website, but even that seems to be too complex of a definition. You see, if you have any familiarity with programming languages, all JSON objects really are hash maps, or in the Python programming language, dictionaries. It's a data structure that is constituted by this key value pair mapping, which makes it not only very easy to read as the computer, but also, as it turns out, it makes it very easy to read as a human as well. Okay, so now that we understand a little bit about how APIs work, as well as how they communicate with each other via these JSON payloads, what are the other sort of more technical or advanced components of APIs should we cover to really start to become familiar with these sorts of systems? Well, as it turns out, there are actually two different types of APIs. The first, which is arguably the most common type of API, is what we would call a REST API. Now, the word REST is actually an acronym for the phrase representational state transfer. Now, the second type of API is called a SOAP API, where SOAP is an acronym that stands for Simple Object Access Protocol. And while there are quite a few differences between a REST API and a SOAP API, basically what it can be boiled down to is that SOAP APIs are much more rigid in their definition and their requirements in order to send and receive a request, or rather to exchange data between two systems. REST APIs, on the other hand, are more generalizable and offer several different ways in exchanging data, and as a result, these ones tend to be more common in practice. Now, on screen right now, I'll actually show a really good article put together by AWS that explains the difference between these two services, and I'll link that down in the description below for you to read. However, for the rest of this video, the context and the type of API we will be referring to will be REST APIs. Now for REST APIs, in addition to just the request and response relationship, as well as the JSON payloads, there are a couple of other things that we should take a closer look at to start to become more familiar. The first thing that I think is worthy to understand is the concept of status codes. Now, a status code is an object returned by the server of an API to sort of let the client who is calling that API understand the results of the interaction. Was it a success? Was it a failure? If it did fail, well, why did it fail? For example, it is most likely you have seen at some point on your journeys through the internet the infamous 404 error code. Now, this is actually a status code returned by the website you are looking at, notifying you, the end user, that that URL or that page you are trying to access does not actually exist. Now, there are many different types of status codes, and I've actually linked a really great cheat sheet in the description below that goes through their values and definitions. But for the sake of this video, some of the most common status codes are 200, which typically means that the request was processed successfully, a 400, which typically means that there was an issue sending the request, most likely because they are missing some sort of argument within the JSON payload, or maybe one of the data types within that payload is not correct. The infamous 500 internal service error status code. This means that there was an issue processing the request and that there's most likely an issue with the logic of the code within that API. 405 invalid HTTP method, and 503, which means that the service is unavailable, or the server that is hosting that API can either be overloaded, simply undergoing maintenance, or something else on the sort of hosting end of things. Now, if you're really brand new to the concept of APIs, you might have caught on that in that 405 error code, I mentioned something about HTTP methods. Well, what the heck are those? You see, because APIs are the way two software systems communicate, this whole concept is actually sort of analogous to the English language. For example, in English, we have different types of sentences, right? We have declarative sentences, we have interrogative sentences, we have imperative sentences, and we have exclamatory sentences. Now, based upon the context of a conversation or the communication between two individuals, that's going to ultimately determine which type of sentence you are going to want to use. Now, an analogous concept of this in the HTTP REST API universe is this concept of HTTP methods. And in general, with APIs, we can perform 4 different actions. This isn't exhaustive, but these are the 4 sort of main actions that APIs are designed to take. And using the acronym CRUD, we can actually sort of easily remember these types of tasks: create, retrieve, update, and delete. As such, there are 4, arguably 5 main HTTP methods that are used to communicate between two systems. Now, the first of these 4 HTTP methods is the GET request, and this sort of corresponds to the R part of CRUD, where we're actually trying to retrieve information. Typically with GET requests, we aren't necessarily sending a payload, for example, but rather we are using other elements of a request, such as variables within the endpoint name or query parameters, to return a desired set of information. A second type of HTTP method that can be used is what we would call a POST request. Now, the POST request can be tied back to the sort of create word within the CRUD acronym. Now, typically with a POST request, we're making a meaningful change within this sort of whole API architecture. And a lot of times APIs are generally used to interact with a database. So if you want to think of inserting something into a database, that type of interaction would most likely be done with a POST request. The third type of HTTP method we have is what we would call a PUT request, and PUT requests are generally used to update an element between two systems, which corresponds nicely to our U letter within our CRUD acronym. And last but not least, we have the delete HTTP method, which obviously corresponds to the D letter within our CRUD acronym. And again, in the context of database interactions, if we would like to delete a row within a database via an API call, we will most likely do it with a delete request. Now, when I was discussing GET requests, you might have caught on that I said we don't necessarily always send a request body as part of a GET request, but we use other types of elements such as query parameters and variables within our endpoint path. Now, if you've ever been on YouTube or other sort of e-commerce website and you've looked at that URL at the top of your web browser, you've probably seen a question mark character. Now, this question mark character is actually a way to signify to the website that whatever comes to the right of it is not necessarily required, but rather is sort of meant to help surface the desired item that the user is trying to seek out. And so when it comes to query parameters, while they are a part of the ultimate end URL, they are not necessarily required. However, URLs also sometimes contain necessary bits of information called path parameters that can be extracted to complete the request as well. And so again, while probably something a little bit more advanced and something you don't necessarily need to know about APIs, you will eventually, if you develop them enough, come across them, and thus I thought it was worth mentioning in this video. Now, while there are many other low-level components of APIs, the final one that I think is worth mentioning here is the concept of headers. Now again, because APIs revolve around communication, I'm trying to draw sort of analogies to the real world here. And if you ever have sent a letter, like a handwritten letter, and had to go mail it at your post office, generally you provide the receiver's name, their zip code, their address, as well as the sender's name, zip code, and address. This is so that the person who receives the message can verify who the sender was and where it came from. In the concept of APIs, headers sort of perform the same basic function. They contain contextual information around the context of this communication, such as what is the data type that is being sent across, what is the data type that it expects to receive, as well as, in some instances, certain passwords, typically called secrets, that allow the sender to successfully send a request to a receiver. After all, you probably don't want everyone on the internet being able to access some API you are developing. Thus, you can implement this concept of secrets to sort of screen out any faulty requests, thereby ensuring that whoever is actually able to get through is a person you want to get through. Now, I've linked another really great article down in the description below going into the concept of headers, but basically at its simplest, and this is a direct quote from the article, headers are the means that you can use to provide extra information about the request. Simple as that. So guys, that's going to do it for today's video. I hope you have a better understanding of exactly what application programming interfaces or APIs actually are, some important terminology when it comes to their overall construction, such as status codes, request and response payloads, JSON, HTTP methods, query parameters, path parameters. We've gone over a ton in this video, and I would honestly just love to stress that if you really want to get good at your understanding of APIs, there's no better way to do it than to simply build some of your own. If you're really serious about developing your API construction skills, I actually have a module dedicated to this exact concept within my software engineering and Python course that I'll go ahead and link down in the description below, whereby we learn the very basics of APIs, how to construct them, how to put them together, how we can use them to access a database that we set up on our local machine, and ultimately how we can construct unit tests to be sure that they work and function as we intend them to. Thank you guys so much for watching, and I'll catch you in the next one. See you there.